This is a continuation of the previous problem. I will call it problem 1a. This time, we will have a rod, same rod, that instead of being horizontal, it will be tilted. I again pivoted about the center of gravity. This is my pivot point. This is point O, pivot point. There is force of gravity applied at the center of gravity to this rod. Let me use red for this. Force of gravity, which is vertically down. Mass of the rod is still given. M is given. Now there is normal force at the pivot N. And there are two additional forces as in the previous problem. One is F1, magnitude is given. Magnitude of the second force that is applied to this end, F2, is also given, and direction is also given. Length of the rod, R, is given. This is R over 2, and this is R over 2. And the angle is provided. So this rod is tilted at angle that is called, we will call it theta. So let me draw a horizontal line. And this angle, angle theta, is also given. So this angle is equal to this angle, and this is theta. Theta is also given. All this is given. We need to find the total torque, tau total, acting on this rod and created by all these forces. As in previous problem, torque created by gravity is equal to torque created by normal force. And it is 0, since R in our formula for torque, distance from the pivot to the point where the force is applied, is 0. Now let's find torque created by force F1. Torque created by force F1 will be, remember, this is cross product, so we are looking for perpendicular components. This is F1. R is from the pivot to the point where the force is applied, from the pivot. Let me think for a second. I'll use this one. From the pivot to the point where the force is applied, this is R1. I bring them together. This is R1. This is F1. No. Yes. I did it right. So R1, F1. What is angle between them? Angle that I'm interested in is this, but angle that is given is this angle. So either you use trigonometric identity and express this angle, angle of interest, angle between R and R1 and F1 as 90 minus theta, and then it will be magnitude of R, magnitude of F, times sine of angle between them, sine of angle between them. This is angle between them, but in this case, it is 90 minus angle that is provided, minus theta, and sine 90 minus theta will be equal to cosine theta. Either you use trigonometric identity, or, and that's what I would do, I just understand that when we find, I forgot right-hand rule. So you cannot leave a vector on the left and scalar on the right. Here's the direction, right-hand rule. Okay, so instead of using trigonometric identities, I would just find the component of R that is perpendicular to F. So this is R. R has two components. One is, I can do it here probably. One is horizontal and another one is vertical. So which component of R is perpendicular to F? It is horizontal. It is this one. And we know magnitude of this component. What is it? It is r over 2, this length. Let me redraw it, make a better picture. So I draw it again. This is my R1. This is my F1. And then I break R1 in components. And I'm looking for this component that is perpendicular to F. Angle that is provided, given me in the problem, is this theta. So horizontal component from this right triangle, I immediately find that it is R1 times cosine theta. So it is R1 cosine theta, F1. This is magnitude of my torque. And now I need to find the direction. And to find the direction, you take your right hand, you put it along R, and we understand that our choices are in or out of the board. So R1, you bend your fingers towards F1, and your thumb shows you direction which is out of the board. If you want to introduce coordinate system, for example, I have a coordinate system with x to the right again, y up, and x, y, z follow the right-hand rule, so z is out. Out means that if I use unit vectors, r1 cosine theta f1 and unit vector k. This is just another form, another way to write it. Finally, I need to replace R1 by what is given. So magnitude of R1 is capital R over 2 cosine theta F1 K. Now we find torque created by F2. What is torque created by force F2? Again, I'm looking for perpendicular components. This is F2. This is let's draw R first. R2 will be from the pivot to the point where the force is applied. So this is R2. Now, component of R2 that is perpendicular to F is this horizontal component. And it is equal to R2 times cosine theta. R2 cosine theta times force F2. I need to figure out the direction. To figure out the direction, I start these two vectors from the same point. This is F2. This is R2. From R2 to F, my thumb shows me direction into the page. And it is equal to R2 cosine theta F2. It is in minus k direction. These two notations, these two lines are identical, but I need to remember to express R2 in terms of what is given. So magnitude of R2 is capital R over 2 cosine theta F2, and this is minus k. All we need to do now is to find the net torque created by all of these forces. Tau total is equal to torque created by gravity plus torque created by normal force, both are 0, plus torque created by F1, which is, I will switch the order, I like it F1, doesn't matter, R over 2 cosine theta F1 K. And the second one is for torque created by F2 is R over 2 cosine theta F2, and it is minus k. We add them as vectors. And if I factor out, can you see when I write here, this will be the last line, I factor out R over 2 and cosine theta. R over 2 cosine theta, let's start with forces, it will be F1 minus F2, I'll also factor out this minus, then R over 2 cosine theta, and it is out of the board or in positive z direction with my choice of coordinate system.